Hey there everyone, I'm Michael, and welcome to another video. This is a story about how I almost allocated 5 terabytes of RAM in Socially Distant. It was a pretty nasty bug that I caused in the game while working on the terminal, and I want to walk you guys through the bug, how it works, and how I fixed it. And this is a continuation of yesterday's video where I actually showed off the new terminal that I've been working on the past few days. So if you haven't watched that video already, please do. I will have it linked in the description below. And at the end of that video, I left you guys with a little quote from Raphael, the previous lead programmer of Restitched and a mentor of mine, where he said, "Programming is all about making mistakes and spending lots of time fixing them. When you see it that way, you can't feel bad about making those mistakes." And that quote holds true with this bug. It was definitely a mistake on my part, but I don't feel bad about it because at the end of the day, we figured it out, we fixed it, and this video exists. So let's get started. By the way, I also rearranged my room today, so if the audio sounds different, that's probably why I have not optimized the microphone yet. So let me know how it sounds, and I will adjust accordingly before the next video. Anyway, let's start. So to understand, the terminal is a window inside the game, obviously, and a window has a width and a height. And by width and height, I mean the width and height of the actual client area, so not including borders or the title bar. So we don't care about this title bar here, we just care about the area of the window where the terminal itself will be. So this entire black area, basically. And the terminal works in terms of characters and not pixels. All terminals are like that, by the way. So when the window width is a certain value and the window height is a certain value, the terminal has to be described in terms of rows and columns. So you'll think of a window as having a width and a height, but a terminal will actually have a column count and a row count. In Socially Distant, by default, the terminal is 132 columns by 43 rows. But if you increase the size of the window, it will obviously have more columns and more rows based on that new size. So that's the basis of how this all works. Now, a row in this game is a line of glyphs, and all a glyph is one single character. So in this alias command here, I zoomed in really far, the A, that is a single glyph. So a row is a row of these glyphs, a line of these glyphs. And the game needs to figure out how many glyphs can fit in a row and how many rows can fit in the window. And that's where the bug starts. That's where it lies. So let's actually look at the code and I will show you guys how we reproduce this bug. So we're going to start in the source code by going to simple terminal render. And from there we're going to go into void update. And there's one line of code here that I'm going to have to change. It is right here, var c8 equals this.lineHeight. We are going to change this from this.lineHeight to this.rendered lines 0.rect.height. It might not be clear what I did there, but I will explain what that line of code means in a second. It is the cause of the bug I'm going to show you guys. So once the game recompiles, which does take a little bit, alright, we are going to stop the game, and we're going to replay it, and we're going to get it loaded up, and we're going to open a terminal. And as you can probably tell, the terminal looks completely fine. If I type help, I get the list of commands, and everything works. But if I go into the game's dev console, we're going to notice a few things. We're going to notice 4 error messages. The 4th one doesn't matter, but the first 3 do, because they say exactly what's going on. Whoa, 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 something needs to be restitched immediately. We've run out of RAM. Now, it's very common for me to make restitched puns in these types of error messages because you're not supposed to see them. They're supposed to alert me that something's gone wrong. And something's definitely gone wrong here. So let's try to figure out what's gone wrong. We're going to hit Control-Shift-P and leave the game and go into the Unity console, and we're going to double-click one of these errors and see where it takes us. As you can see, it takes us to this xrealloc function that takes a reference to an array and a size as an integer and returns an array. And what this function does is we start with this try-catch block. And inside this try-catch block, we check if the array is null, and if it is null, then we just create a new array with the given size and set it to the array variable. If the array was not null, then we just use C#'s array.resize method, passing a reference to the array and giving it the size, which will create a new array and copy the old data over. However, if we catch an out-of-memory exception, we will end up in this catch block where it writes to the console, whoa, 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 something needs to be restitched. Immediately, we've run out of RAM. Now, if we make it this far out of the catch block, we will end up returning the array. This tells me something. This tells me that we are actually getting an out-of-memory exception from these 3 lines of code here, because otherwise we wouldn't get this printed to the console. That's the condition that causes that console log. So let's attach a debugger and get it to reproduce the issue. Give it a minute to attach to the debugger. There we go. So we're going to close the terminal. Oh yeah, you have to unpause. My bad. Alright, so we're going to unpause, and then we're going to close the terminal. And we're going to reopen it. And we've hit that breakpoint. So let's have a look. Now, at this point in the game, we've hit this catch out of memory exception, and we're about to write that console log. Now, let's have a look at the 2 values we were passed in the function. We will look at array, and specifically, if it is null, which currently it is not, so then we can look at its length, and we're going to find out that it is 43. So that gives us a clue as to what this array actually is, but let's look at the size that we're trying to resize it to, and 2.147 billion. If you're a programmer, you probably know what that number is. It is the maximum value for a 32-bit integer. That is not ideal. What's going on here? Well, let's have a look at the stack trace and find out what's calling this xrealloc method. And we end up in the resize method of the terminal, where we're executing this line of code here. This.size equals xrealloc ref term.row, or term.line. Oh my god, I cannot read. Term.line equals xrealloc ref term.line row. I don't know where I got this.size from. Maybe because I was thinking of resize, and I can't read. I am blind, so my apologies. Anyway, so we're basically taking term.line, we're passing it to this method here, this xrealloc method, and we're giving it row as the size, and it's going to return the reference to the new array that it creates into term.row. So, that tells us that we're reallocating the term.line method, or term.line array. But what is row? Well, row is 2.147 billion. So where's that coming from? Well, let's look at what called this.resize. And if we click on it, it takes us to this if statement here, where we're checking if r is not equal to term.row, or c is not equal to term.call. And if that's not, or if that's the case, resize will get called passing c to the col variable and r to the row parameter. Now, what's this entire section of code doing? Well, first, we're in the update method, and what we're doing is we're getting the new window width and new window height of the terminal, and we're checking if our current window width and current window height are not equal to these values. And if that becomes true, then we're setting our current window width and height to the new window width and height. We are checking if we're not already drawing, and if we are drawing, then if we're not drawing, then we will draw now. And then we're getting these CW and CH floating point numbers here. CW is character width, and CH is this dot rendered lines rendered lines 0 dot rect dot height. And then we're taking CW and CH, and we're saying, well, R is going to be equal to math.round WH over CH casted to integer minus 1, and C equals math.round window width over CW casted to int minus 1. So that's what we're doing next. And then after that, we're saying R is equal to math.max of R or default row count, and C is math.max of C or default column count. And then we get to this if statement where we inevitably call resize. So we care about what R, C, CW, and CH are. Those are the values we care about. Well, if we look, and we also care about the window width and window height. Well, if we look at WH, or first WW, we're going to see that it's looking normal. 950, that's a standard size for a window. That's nothing too major. And if we look at WH, same deal. It is nothing to worry about. It's 600. The window is going to be 950 by 600 pixels, or units. If we look at CW, we're going to see that it is a floating point number equal to 7.2 plus a little bit of error. And then if we look at CH, well, it's 0. Well, that's not ideal. Now, if we look at R, we're going to see that it's 2.147 billion, which is that bad value that's causing all our problems. But if we look at C, we're going to see that it's normal. It is 132. We can also, if we want to, we can look at default row count, which is going to be 43, and default column count, which is going to be 132. So something is causing R to be int.max value. Now, what would that be? Well, there's two lines of code that we care about here. We care about the assignment of R with the max, or math.max here, and we care about the initial value of R. Well, it can't be the math.max because we're just passing R as the first parameter and default row count as the second parameter, and math.max will take the two parameters and return the larger one. So that tells me, since we know that default row count is going to be 43, R had to have been bigger than 43 to get set to R again. So that tells me that it was already 2.147 billion when this code executed. So then we have to look here at R equals math.round WH over CH casted to int minus 1. Well, what could be going on here? Well, let's remind ourselves what WH was. We know WH was 600, but we know CH was 0. And we're dividing WH by CH. Well, if we do that, we actually get infinity, or float.positive infinity. And the interesting thing is math.round, when you give it a floating point number, what it will do is it'll round it to the nearest integer. So the idea here is that if you give it something like 0.8f, we should get 1. And if we give it 0.3f, we should get 0. So that's handy for turning a fractional number into a whole number, which is what we want here. We don't have a concept of fractional rows or fractional columns. We want to know how many rows and columns the terminals can support, given the window size. But then we want to cast it to integer because we don't want to deal with floating point numbers. Well, if we do math.round of WH over CH, it's just going to return infinity. Infinity is not a number, so if you try to round it, you're just going to get infinity. But what happens if we cast it to an int? Well, we get negative 2.147 billion, or int.min value. So then what we do is we subtract that from, or we subtract 1 from that. And that returns 2.147 billion, or int.max value. Why? Because we started with int.min value, and we subtracted 1. And because this is a game engine and we want performance, we have overlap hex, or overflow hex disabled, so it'll arithmetic underflow on us, and we'll end up wrapping around to the max value of the integer. And that will become r. Now, the way to fix this is simple. We need to use font metrics to calculate the line height instead of using the rendered lines array. Because what's happening here is when we first open the terminal, no text has been added to the terminal. So TextMesh Pro has not measured how tall the line should be because it doesn't have any lines to measure. So we're getting 0 as rect.height here. So to fix this, we're going to use TextMesh Pro font metrics instead, which I've already done in the line height property. And all that does is it takes our current font size and it multiplies by 0.01 to turn it from points to EM scale. And we combine the line height and the negative of the underline offset to get the total line height, and then we multiply that by EM scale to account for our font size difference. And that will get us our line height, and that will fix the bug. But we're not done yet, because yes, we've fixed the out-of-memory exception, but I told you at the beginning of the video, this is how I allocated 5 terabytes of RAM. Where did that come from? Where did I get 5 terabytes of RAM from? Well, at the start of the video, I told you guys that the terminal works in terms of glyphs. And there's a structure in the game for glyphs that stores all of their data. It's in glyph.cs. Now, if we look at it, that is not actually what I wanted, but we are in a great place. We're in the line struct. A line is just an array of glyphs, and so an array in C# is going to have 8 bytes for the memory address, or 4 bytes if it's compiled for 32-bit, but it's going to be 8 bytes in this case because it's 64-bit. And then there's going to be some extra header information for like the length of the array and stuff like that, but we're not going to concern ourselves with that. We're just going to consider this struct to be 8 bytes long because the memory address of the array is going to be 8 bytes. So we'll start by opening a calculator here, and we're going to do 8. Now, if we look at what a glyph actually is, we're going to see that it's a uint32 U, which is a Unicode character. We're going to have some glyph attributes. Glyph attribute is an enum that inherits from ushort, so it's a 16-bit integer, 2 bytes, but because we have the two 32-bit integers down here, these are going to be 4 bytes, so it's going to get padded. So effectively, this glyph structure is 16 bytes long. And we can prove that by doing size of glyph. And it returns 16. Now I can't actually take the size of line because of the array. It causes it to be a managed type in terms of C#'s compiler, so it won't let you do that. But glyph is considered unmanaged because there are no managed references in it, so we know that it's 16 bytes. But we're going to have to estimate line, and that's where I got 8 from, because I'm counting the array and its memory address. Now, like I said, a line is a row of columns. Now we know that the terminal is going to be 132 columns from before. So what we can do is, in our calculator, we can add 132. I've been informed that the Windows calculator in standard mode does not support brackets. That is dumb. Microsoft, you should fix that. Brackets are basic standard parts of math. Anyway, inside brackets, we're going to do 16 times 132 and add that to 8. And we're going to get 2120 bytes, 2.12 kilobytes. Common misconception, a kilobyte is 1,000 bytes, whereas a kilobyte is 1,024. So we're working in terms of kilobytes, megabytes, gigabytes, all that. Those are all multiples of 1,000. So this is 2.12 kilobytes. Now, remember that, because we're allocating an array of these line structures, and we're allocating 2.147 billion of them. Now, if we go ahead and grab our int.max value from the debugger here, we're going to see what it is, and we can copy that text as a number, and in the calculator, we're going to hit multiply by that value, and we are going to get 4,552,665,331,640 bytes. Now, obviously, if we divide by 1,000, we're going to get 4 billion kilobytes. Divide by 1,000 again. We are going to get 4.552 megabyte, or 4.552 million megabytes. We're going to get 4.552 terabytes, or 4,552 point that number gigabytes. So needless to say, this is a very large number. This is a very large amount of RAM that I'm reasonably sure none of you guys have, and I know I certainly don't have, because I only have 64 gigs. This is one of the only times where you will ever hear me say I only have 64 gigs of RAM, because realistically, I don't need any more than that, except for when these bugs happen. Now, interestingly, we're actually being lied to, because we got that error 3 times, right? Now, if we look at the resize method to find where that error came from, the 2 other errors, the first one is term.line, which we know is going to be 4.5 terabytes. And then term.alt is the exact same type of array. We're allocating it to the exact same number of elements. It's a line struct with a certain amount of glyphs in it. And so we can actually multiply this number by 2 to get 9.1 terabytes of memory. And then we're going to allocate the dirty array, which is where we get the next error here. And the dirty array is just an array of integers being allocated to the amount of rows we have. So for this one, we can just do we're going to do 2.147 billion times 4, because that's the size of an integer in bytes, and as you can see, that is the number that we get. Or, no, it's not. I'm dumb. I apologize. That's what happens when I add... okay, no, we did this wrong. Ignore that entire parentheses, subtract it from the whole thing. But if I had not actually divided the terabytes, or divided the bytes into terabytes, then this would be accurate. Either way, we're talking about just shy of 9.2 terabytes of RAM being allocated. And you know what? All of that happened from one little mistake in one line of code that ultimately resulted in the game dividing by 0, causing an infinity value to be returned, rounding that, casting that to int_char, causing int.max or int.min value, subtracting that from 1, or subtracting 1 from that, sorry, causing it to be int.max value, and then we allocate an array of that size, which completely blows up the terminal. And with one line of code being changed and fixed, we can now start the game up again. And once it loads up here, we end up running a terminal, and there are no memory errors going on in the console. With that said, as always, I'm with Michael. This is the story of how I allocated not 5 terabytes, but actually over 9 terabytes of RAM. And as always, hope you learned something, hope you enjoyed the video. I'll see you guys in the next one. Thanks for watching.